So hello everybody, we are dealing with the problem on capacitors and dielectrics from JEE Advanced 2022, and it is more than one correct type problem. The problem is stating a medium having dielectric constant K greater than 1 fills the space between the plates of a parallel plate capacitor. The plates have large area and the distance between them is d. The capacitor is connected to a battery of voltage V as shown in the figure A. Now both the plates are moved by a distance d by 2 from their original position so as to attain the configuration which is given in B. In the process of going from the configuration depicted in the figure A to that in the figure B, which of the following statements is or are correct? We need to think about electric field, capacitance, voltage and work done in the process. So in case you want to give this problem a try, you can pause the video here and think about it, or otherwise continue watching for the solution. So let's get started with the solution. So in the first part, the most important thing which we need to mention here is that since it is connected to a voltage supply, so V is equal to constant throughout the process as the process shifts from configuration 1 to configuration 2. So over here the statement C is stating that the voltage between the capacitor plate is increased by a factor of K plus 1. So this statement is incorrect the moment we write V equal to constant. So C is chopped out. C is not the correct option which we are looking for. Now in this part we are calculating the capacitance. So capacitance of the parallel plate capacitor associated with this dielectric is K times of epsilon naught A by D. So this is the capacitance associated with this part. Now when the plates are separated, over here if I say that the capacitance associated with this one is C, this is C2 and this one is C3, and the three are in series with each other. So over here I can say that C2 and C3 are equal to each other, and it is equal to epsilon naught A by D by 2. So D by 2, so it will become something like this. And capacitance associated with 1 is equal to epsilon naught A by D, and then we have K times epsilon naught A by D. And then if we write 1 by C series, so 1 by C series is equal to 1 by C2, 1 by C1, 1 by C3. So 1 by C2 is equal to twice epsilon naught A and then D. So 1 by C2 and then 1 by C3, so we are multiplying this value by 2, and then we have D upon K times of epsilon naught A. So over here if we solve for the capacitance, so the capacitance value over here turns out to be that C series is equal to K times of epsilon naught A by D K plus 1. So by D K plus 1. So this is the final capacitance value that we have. So capacitance is decreased by a factor of 1 by K plus 1. So initially it was K epsilon naught A by D, and now it is K epsilon naught A by D K plus 1. So it is decreased by a factor of K plus 1. So this option is absolutely correct. So for this particular problem, alternative B is correct, but we still need to check for option A and D. So over here the voltage supply is maintained. So in the initial part, if we are looking for Q equal to CV, so Q equals C1 times V, so it will become K epsilon naught A by D times V. So this is the value of charge which the capacitor holds initially. And if we calculate the electric field associated with this, so electric field will become sigma by epsilon naught. So K epsilon naught A V by D, and then we divide by epsilon naught. So electric field in the region which is filled with the dielectric is equal to K times of epsilon naught A by D times V. So sigma by epsilon naught will give us this value, where sigma is obviously divided by area. So we need to divide by area as well. So we are getting this value as and divide by epsilon naught. So over here we get K times of V by D. So K times V by D is the value which we have when the air will be connected in between. Now in the presence of dielectric, so this is E in case of air. So E in case of dielectric. So E in case of dielectric will be written as V by D. Now in this scenario, the value of electric field will change because of the change in the value of charge. So if we calculate the value of E due to dielectric in B scenario, so E due to dielectric in B scenario, then it is equal to E in air in case of B divided by the dielectric constant, which is K. So charge in case of B by K times of A epsilon naught. So over here we write it as epsilon naught A KV by D times of the capacitance value we are using, A epsilon naught, and on solving this we obtain V upon D K plus 1. So this is the electric field in B case in the dielectric. So we calculate the value of charge first, Q equal to C series times V. So C series we are using K epsilon naught A by D K plus 1, and then we are using the term V and then dividing by this dielectric constant value to calculate electric field in the dielectric. So over here the first alternative is stating the electric field inside the dielectric material is reduced by a factor of 2K, but it is not so. It is initially the value is V by D and finally the value is V by D times K plus 1. So it is not reducing by a factor of 2K, so this alternative is also incorrect. Now we are trying to check the alternative D. The work done in the process does not depend upon the presence of dielectric material. So if we solve for this part, so if we calculate the initial energy associated with this dielectric capacitive system, then it is equal to half C1 V square. So half the value of capacitance is equal to K epsilon naught A V by D, K epsilon naught A V by D, and this is the value of charge. Capacitance is K epsilon naught A by D, so K epsilon naught A by D times V square. So this is the initial value of energy. If we calculate the final energy, then it is equal to half C series V square. So since voltage is constant, we are using the expression half CV square. If charge is constant, then we use the expression Q square by 2C. So for C series, we have K epsilon naught A by D K plus 1. So half of K epsilon naught A by D K plus 1 times V square. So if we calculate work done, so work done in the process is U final minus U initial. So if we calculate U final minus U initial, so we write it as K epsilon naught A V square by D taken common. So in the final part we have K plus 1 minus 1. So over here on solving we obtain half of K epsilon naught A V square by D 1 minus K minus 1 by K plus 1. So over here we obtain a value half of K epsilon naught A V square by D, and over here we are left with minus K upon K plus 1, or we can say minus K square upon K plus 1. So this value is not matching with alternative D. So alternative D is suggesting it should be does not depend upon the presence of dielectric, but it is depending upon K square upon K plus 1 with a negative sign. So we can say that alternative D is also incorrect for this particular problem. So since this was more than one correct type, so we checked for all the alternatives, and after checking for all the alternatives we can say that only option B matches for this particular problem. So this was JEE Advanced problem 2022. So what we have done, so we initially calculate capacitance for this part and then we calculate charge. So we calculate C1 and then we calculate charge using Q equals CV, and then using the aspect that electric field in the dielectric material is electric field in air divided by its dielectric constant, we check for the dielectric constant, the electric field in the dielectric material. And on the B part, we calculate the individual capacitance value, then we calculate the series value of C equivalent or C capacitance to obtain this value. Then we follow the same process, Q equals C series V, and then for the material of, we write E air divided by the dielectric constant. In both the cases, since the voltage is constant, so V equal to constant, so we are using the expression half CV square to calculate the energy associated with both the process. So initial energy and final energy is calculated, then we subtract the two to calculate the work done. So this is the process to solve this kind of a problem. I hope you enjoyed watching this video. To watch more such serious content, continue to watch the channel. Please like, share and subscribe.